Hey everyone, so in the last video we studied Git branching and why is it super useful in a production project where you will have multiple people contributing to the same code base. So we first made 3 commits to our master branch, then we moved back to second commit, and from there we created a new feature branch. Then we switched to the feature branch and there we ended up making 2 more commits. In this video we'll be studying how to combine changes between different branches, because while Git branching does allow us to make any code modifications within our feature branch so we don't affect a separate branch that someone else is working on, it's also important that once we are sure that whatever code modifications we have made in our feature branch is good, we have tested it properly, we then need to combine those changes. We have to incorporate those changes into our main or master branch, and that is where git merge command comes into action. So let's get back to VS Code, and as you can see, this is our Git repository which we have been working with. Let's open our terminal. This time, instead of working with PowerShell, we will be working with Git Bash, which is the native terminal that we get when we download Git. And as you can see, it has a very familiar, like people who have worked with Unix or Bash will see this as a very familiar interface. Let's do some sanity checks. So running git status will tell us that we are on feature cloud plan branch and there is nothing to commit. We can also check what branches we have by running git branch --all. And as you can see, we have master branch and feature cloud plan branch. Okay. So before we start merging branches, let us create a new branch, and this time instead of using master, we'll be using feature branch as our reference. So while we are on this feature branch, we can create a new branch using this command git branch and the name of the branch, right? This is all revision. We've already done this in the last video, right? We will name our branch as, let us name it as AI skills, right? So we'll be adding what all AI skills we need to learn along with the rest of data science and machine learning stuff. Let us run git branch all and check whether we have created the new branch, and we have. Let's now switch to that branch. Right, so we have switched to our newly created branch. We'll clear everything and we'll run git status for sanity check. So we are on branch feature AI skills. There is nothing to commit. Let us now add a new folder, AI skills, and we will be adding new files here, right? So first we'll be adding langchain.txt. For people not familiar with LangChain, it is basically one of the frameworks that allows us to create AI agents, right? So plan to learn LangChain for creating AI agents in production. Okay, we can save this. We will run git status, and now it will tell us that we have an untracked file under AI skills folder, which we will first be adding to our staging layer using git add dot. And running git status again will tell us that we already have some changes in our staging layer and we can now commit them, which we will do by running git commit -m and then our commit message, added plan to learn LangChain. Okay, let us add one more file, and that will be vectordb.txt. Here we will be adding our plan to learn vector databases like Pinecone and ChromaDB. So vector databases are important when we are creating AI applications because they help us store our vectorized data. So now that we have created this, we will have another file which is untracked. So we will be adding that vectordb.txt file to our staging layer. And now we have to commit that change to our local repository. Create plan to learn vectordb. Again, running git status will tell us that we are on branch feature AI skills and there is nothing to commit and our working tree is clean. So we have added 2 more commit messages on our newly created feature branch feature AI skills. Okay, so let's clear this and visualize our branches and commits from command line. We have already used this command before, git log, one line, decorate, graph, and all. As you can see, we have added these 2 commits to our newly added feature branch. And we can also visualize this on git lens. It was at this point on feature cloud plan branch where we decided to create a new branch, feature AI skills. Then we switched to that branch and we added these 2 commits. First a langchain.txt file and then a vectordb.txt file. And currently we are on feature AI skills branch with our latest commit being this one. At this point, we want to run git merge command and merge these changes that we made to our feature AI skills branch into our feature cloud plan branch. What you have to remember before making a merge between branches is that anytime you want to merge some changes into some branch, you have to make sure that you switch to that branch. So our head, instead of being pointed at feature AI skills branch, should be pointed at feature cloud plan branch, and then from that branch we run the merge command to bring the changes from this branch. So we will be switching to recipient branch where we want to bring the changes into. From here we will be running the merge command. The name of our branch in this case will be the branch where we are going to bring the changes from. So in this case we want to bring the changes from feature AI skills branch into our feature cloud plan branch. Before we go look at the output of git merge command in detail, let us run git log command to visualize the branches. So what Git did when we ran this git merge command is it essentially fast forwarded this commit 4cfeecb. So that was the commit at this point, and that was the point where we had our feature cloud plan branch before we ran git merge command. It took this commit and it fast forwarded it to this commit 7a8c244, and that was the commit which we had on our feature AI skills branch. You can see it here. Our feature AI skills branch had 7a8c24 as its latest commit. Our feature cloud plan branch had 4cfeecb as its latest commit, and it essentially just fast forwarded our feature cloud plan branch to catch up to the latest commit on feature AI skills branch. And the two files which got added to our feature cloud plan branch from feature AI skills branch, we can also visualize this even better on Git Lens. And as you can see, previously we had our feature cloud plan branch here, and now it's located in the same commit space with feature AI skills branch. So just to visualize at a high level what we just did. So at this point where our head is pointed at feature cloud plan branch, we created feature AI skills branch, then we switched to it, we added langchain.txt, we added vectordb.txt, and at this point we have decided that our changes look good, so we wanted to merge our feature AI skills branch to feature cloud plan branch. We had to first switch to our feature cloud plan branch because that is our recipient branch. From that branch we now ran git merge command to merge the changes from feature AI skills branch, and it's even more intuitive here that all we need in order to combine the changes between these two branches is to make sure that we just fast forward our feature cloud plan branch to catch up to feature AI skills branch. And that is what was the end result of our git merge statement. At this point we can delete our feature AI skills branch because we won't be needing it anymore. To do that we can use this command git branch -d, the name of the branch. And we often do this where we create a feature branch just to solve a particular problem, resolve a bug, etc. And after we are done merging to our central branch, we end up deleting it. Because Git branches are quite cheap like that. We can create them and delete them at will. The only thing we have to be mindful of, obviously, is that we have merged those changes to some other branch before deleting. Okay, so let's clear this and run our branching view command. Oops, misspelled it. Okay, so as we can see, we have our master branch and our feature cloud plan branch, while the feature AI skills branch has been deleted. Now let's switch back to our master branch. It's been a while since we have worked on it. Now usually what happens in production projects when you're working for a company is there will be a central branch. It's either a master branch or main or develop or release, which no one can make direct commits to, right? So no one will be directly working on master branch or main branch or develop branch. But what happens is different team members create feature branches using the central branch as a reference and then submitting requests to merge those changes to the central branch. But in this case, we will be just adding changes directly to master branch. So let us add one more change to the master branch. So let us delete this r.txt, right? So we will for now just give up learning R, run git status for sanity check. So as we can see, it has noticed that we have deleted r.txt. Let us stage that change and commit clear, and then running git status. We are on branch master. There is nothing to commit. Git log, and then visualizing this over Git Lens, you can clearly see that we have our master branch which has this direction where we recently added this commit, and we already had some changes which we committed in this feature cloud plan branch, which it seems like there is a divergence between our master and feature cloud plan branch, with this commit being their common ancestor. So what happens if we try to now merge changes into our master branch from our feature branch, right? So let's go back and try to run we already are on master branch, right? So we don't need to switch to it. We can simply run our merge statement here, and the name of the branch that we want to bring changes from is feature cloud plan. So you can clearly see now that the Git response when we ran this merge statement is different to what it was when we tried combining feature cloud plan with feature AI skills. In that case, Git simply ran the fast forward merge and completed the merge without asking us to give it a commit message. In this case, what seems to be happening is Git is asking a response from us, right? It's telling us that it is waiting for our editor to close the file, and the file it's referring to is this one, merge message. So Git is essentially asking us to write a commit message for this merge statement. Okay, so let's customize our commit message, save it, close this file, and at this point it has made the merge, right? So in this case, there are two clear differences between this merge state compared to the merge that we had when we were trying to combine changes between feature cloud plan and feature AI skills branch. First one is that when we ran this merge statement, Git waited for us to complete the commit message, and that wasn't the case when we were trying to merge using fast forward, where it simply completed the merge without asking for a separate commit message. And second aspect which is different is the strategy which Git seems to have employed for completing this merge statement. Previously, when we finished our merge, it was by fast forward. In this case, it seems to be by ORT strategy. Now, Git has a good documentation on what ORT means in this context, and I'll link it in the description, but it's basically a merging strategy that Git employs where it resolves two heads using a three-way merge algorithm. Right now, what does this mean? Let us go to Git lens, right, to understand this visually. When we began our merge between master and feature branch, we had a situation where our master branch was headed in this direction, with this being its head commit, deleted r.txt, whereas the feature branch headed in a different divergent direction with added plan to learn vector db being its head commit. The difference in this scenario compared to what we had when we merged between feature cloud and feature AI skills branch is that in this case, there is a common ancestor between the two branches, and then the branches are divergent from that common ancestor, right? So if we just go back to the visual summary of our previous merge, so this was our previous merge where our feature cloud plan was a direct linear ancestor of our feature AI skills, right? In this case, there is no divergence. But in master, even here, right, before we deleted r.txt, you can see that our master branch is basically divergent from our feature cloud plan branch, right? It's not a direct linear ancestor. Rather, there is a common ancestor between both master and feature cloud plan branch. And anytime you have a situation like that, right, where the two branches that we are trying to merge into one another have common ancestor and neither of them is a linear ancestor of the other, Git tries to implement a three-way merge algorithm where it looks at the head commit of the master branch, right, in this case, which is our recipient branch, and it looks at the common ancestor commit and it tries to find out the difference between the two, and then it also looks at the common ancestor commit and the head commit of our incipient branch, the branch from where we are trying to bring the changes, and it tries to find the difference between the two, and it uses that three-way comparison to merge the head commits of our two branches, in this case master and our feature cloud plan branch. And once it finishes the three-way merge algorithm, it then waits for us to write a commit message for that merge. So this is our commit message, and once we wrote it and we saved it and we closed that editor is when Git finally completed that merge, and you can see that these two branches have now been merged with this particular commit message. Okay, so now that we understand how to merge changes between different branches, let us get into merge conflicts, which happens when you have different people making changes to the same file. So anytime you have a situation where one team member makes change and then you have another team member which makes change to the same file, then you will have a conflict when you try to merge those two changes. So let us get back to terminal, clear this, run our branching command again, git log one line decorate graph all. Okay, so currently we are on master branch. Let us make two changes. Okay, say we want to change our calculus.txt file, and what we also want to plan for is to learn matrix calculus, because that's important for understanding backpropagation, right, among other things in neural networks. Okay, save. Then we can run git status. We can add this change to the staging layer. and we can commit this change to our repository. Edit plan, or rather we didn't add it, we modified it, right? So we modified plan to learn calculus. Okay, we clear this, and we also make one more change, say to python.txt, where we also now add plan to learn AI framework libraries like LangChain and LangGraph. Okay, Control S, then we run git status, we add this change to our staging layer and commit this. Okay, run our git branching command again. As we can see, we added this to commits to our master branch. Let us switch to feature cloud plan branch and modify the exact same files that we did in master branch to mock merge conflict. So we will switch to our feature branch, running git status to make sure that we are on feature branch. And at this point, obviously you can't see the change we made in the master branch, right? Because we are on feature branch. Let us make a change here. Python is also better AI programming language than R. Control S, and we run git status, add this modification to our staging layer, and we commit that change to our repository. Then we go to calculus.txt and modify this by adding our plan to learn matrix calculus, necessary to understand neural networks. Okay, Control S, running git status for sanity check, adding this to our staging layer and committing this. And then again running our git log command to visualize branching. And as we can see, at this point our branches have diverged, where we added 2 commits to master branch, 2 commits to feature branch. Much better way to visualize this will be git lens, where we'll be able to see that same thing. So at this point is where we made the commit to merge our feature and master branch. And from there we created this 2 commits on the master branch, and we created this 2 commits on the feature branch. And currently we are on feature branch. Okay. Now switching back to master branch, let us see what happens when we try to run a git merge statement now to merge our changes from feature branch into master. And this is what we are trying to understand here. This time when git tried to auto merge changes, it ran into conflict. And as the git output states here, it tried to auto merge calculus.txt, but there is a conflict there, and it tried to merge python.txt, and there is also a conflict there, which is why it could not finish automatic merge. It is asking us to fix the conflicts and then commit conflict resolution. Now there are 2 ways broadly that you can handle this. First is we go to the file. So in this case, let us first try to resolve calculus.txt. So as you can see, calculus.txt is open here. Even if it wasn't open, you can open it, right? So you can maybe close this files, and then based on what the git output tells, we can resolve conflicts one by one. In this case, let us go to calculus.txt, and you can see it has an exclamation mark here to indicate that this is one of the files which we have to resolve conflict in order for us to finish this merge. If you look at the output here, we have our head, which was pointed at master. Remember, that is where we switched to before we brought in changes from feature branch. Anytime there is a conflict, the way we'll be able to see that conflict in the editor of your choice will be like this, where it will have some artifacts or decorators like head, and then the name of the branch that you are trying to bring these changes from, and then this equal to signs. What Git is telling us here is your current branch, which is where your head is pointed at, has this content, and your incoming branch, which is your feature branch, has this content. Now what do you want to do about this, right? And this is where we basically just go inside and decide for ourselves what we want to pick and choose. Say I don't want this, right? Because dates and topics are repeated between both the branches. Between these 2 messages, I want to keep the one which I had in my master branch, because that seems to be more descriptive. So I'll get rid of this. And then I can get rid of these artifacts. I can get rid of this equal to signs, and I can get rid of this head artifact also. And that's it. This is what I want my final state for calculus.txt to be. So I'll just Control S, and this part is resolved. Now there's another file which also have to resolve, which is python.txt. So let me close this file and go to python.txt. And this is where we'll now use another way to resolve this in VS Code, which is this option is resolve in merge editor. So if we select this, it will open a view of this conflict, which is a bit better than what you had in the file itself. As you can see in this view, we have on the left side changes that we are trying to bring from feature cloud plan branch, and on the right side we have changes in our master branch, and at the bottom is VS Code telling us that if you want to keep everything between both the branches, and this is how it will appear. Then we can decide for ourselves like what exactly we want to keep between the two branches. So in this case, for example, what I want to do is I want to keep changes from both the branches, right? It makes sense to have line number 4 as well as line number 2 both present in our final resolved state. I can just complete the merge from here and it will ask for a commit message, or I can use another approach to fix this. Okay, so let me close this and go back to the conflict. VS Code also, along with giving this decorator view, it also gives us this options. At the top here, we have accept current change, accept incoming change, which is a change which comes from feature branch, and accept both changes. Okay, and in this case, because we have decided we want to keep our changes both from master branch as well as feature branch, we can use this accept both changes option, and it will keep the entire thing between the two branches. Now, obviously, I still don't want to keep this line because it's getting duplicated. So I'll get rid of that and I will save this. And at this point, we are done with our conflict resolution, right? We have resolved the conflicts both in calculus and python.txt. The only thing left for us is to commit these changes. So if we run git status, it will tell us that we have these two conflicts which we resolved. So we have to still repeat the same process we did for normal commits, right? We have to add this to our staging layer, then running git status again. These changes now have to be committed, and we can commit them. We can just say resolved conflict, and that's it. And the moment we did that, you see that those exclamation marks that we had on these two files have gone, and we have our changes. We can visualize this using git lens, and you'll be able to see 2 commits in our master branch as well as 2 commits from our feature branch have both been merged into this common resolved conflict message. So that's it for this video. We went through how to run git merges as well as how to resolve any conflicts that may arise from it. In the next video, we'll be learning about how to push these changes which we have locally to GitHub.